Hi guys, for today, I'm going to teach you guys about some of interior angles. And what you guys are going to do is you guys are going to be taking a test on all the topics that we have been doing so far in terms of some of the interior angles, the Cavalier's principle, and the very first thing that we did was triangle inequalities. So all those three things would be combined into one as like a summation. Um, Instead of taking a quiz on that, I'm going to give you a test grade for that, and then we're going to move on to other topics after that. Okay. So, some of the interior angles, we're going to be talking about a lot of polygons and how regular polygons, which means from this point onwards, whenever I say regular polygons, I want you guys to understand that means same sides and same angles. And that's what I always want you to remember. Okay? And there's a pattern in which how you guys can solve for this. Regular polygons have a what we call interior angles and exterior angles. As the name suggests, the interior angles are basically the angles inside the polygon. So if we're considering a triangle, angle is inside of it. The exterior angle is always the supplementary angle to the interior angle here. So if we were to draw this triangle out in a more like this way, this same angle that's going to be existing here, well, that is going to be your corresponding exterior angle because this part plus this part, these two would give you 180 degrees in total. So that's how you can figure out what the exterior angles mean. This is all for the sake of just understanding what vocabularies are. But what's really important is if you understand how to do this table and how to solve for these questions here. Okay, so let's get started. So equilateral triangle, square, regular pentagon, regular hexagon, what do they all mean is that all the sides are the same and all the angles are the same. So if you were to think of a drawing for each of these figures, a square would be like all of these figures, going like this, and regular pentagon would be, five sides, but all the sides would be the same. So what I would like you to do is I would like you to draw them out and really get that into your head. Regular hexagon would be something like that. Okay? Now, obviously, if we're thinking about the number of sides here, equilateral triangle, that's 3, square is 4, regular pentagon is 5, regular hexagon is 6. There are obviously a lot more that's going to come in here in your way. So all of these has to do with Greek prefixes. When n is 7, when n is 8, when n is 9, when n is 10, and when n is 12. These are the Greek prefixes that I want you to remember for your homework. Greek 7 should give you septa, octa, and nona, deca, and then dodeca. And then what you're gonna do is just like how we say pentagon, hexagon, like all of those uh, polygons have the word gon at the end. So the polygon that represents n to be 7, in other words, number to be 7, you use a Greek prefix called septa, and then just say gon. So septagon, octagon, as you already know, it's a like a UFC ring. We call it the octagon because it has 8 sides, okay? And it's perfectly regular, which means all the sides and all the angles are the same. Nonagon, it means 9. Decagon means 10. Dodecagon means 12, okay? So solve each interior angle and each interior angle. Now, how do we figure this out? Well, it turns out that we can use something called a pattern. For triangles, guys, you guys should all know that when you guys add all of these angles up, it becomes 180 degrees. And because each interior angle, well, that's each of these guys, we should all know that that's 60 for equilateral. Why? Because simply you take this 180, right? And if you divide by the number of the sides n, which is 3, it actually gives you 60 because 180 divided by 3 is 60. Now let's talk about square here. Square all the angle adds to give you 360. Right. And then now, each interior angle we already know it's also 90 degrees. Well, how do we go from 360 to 90? Same as the pattern above here. It's 360 divided by 4. Okay, and I want you to take a look at the pattern this way too. How do we go from one after the other? Is that pentagon and hexagon is rarely talked about, so not a lot of people know about it. But the pattern here is that every single time when you go down the list, as the number of sides gets increased by one, some of each interior angle actually gets increased by 180 fold. So the next one is 360 plus 180. Just like how it's 180 plus 180 gave you 360. Then you keep on adding 180s to it, which gives you 540 for this one. And the next one after that, if you add 180, it becomes 720 degrees. And just like before, how we figure each interior angle, what each of these angles are going to give me, well, then that's 540 divided by the number of sides, which is 5, which gives you 108 degrees. 720 degrees divided by 6, because it's a hexagon, gives you 120 degrees. And also notice that as long as you go down the list of here, each interior angle should get bigger, but there is no specific pattern. This increases by 30, this increases by 18, so there's really no pattern, but this will consistently give you 180 degrees. So for now, what I want you guys to do is I want you guys to take a look at this formula and really, really jot this down. The sum of the interior angles, you guys are going to be using this a lot, n minus 2 times 180, where n is the number of sides, like I established. Okay, and why is that? Because if you go to the slides here, the previous slide, number of sides was 3 for equilateral triangle. Okay, so if you use the formula, if you subtract, if I were to make a separate column, let's say I erase all of this part, okay, and if I were to create a separate column that represents all of these values minus 2, so for example, 3 minus 2, 4 minus 2, 5 minus 2, and 6 minus 2, well, what ends up happening is that they give you 1, 2, 3, and 4. And so if you were to take these numbers respectively and multiply by 180, you actually get this equivalency. 2 times 180 is 360. 1 times 180 is 180. 3 times 180 gives you 540, and so forth and so forth and so forth. So this always works. The sum of the interior angles is always n minus 2 times 180, and then what you're going to do is you're going to find each angle of a regular polygon. In other words, the last column, each interior angle. Just like before, you take the sum of the interior angles, which was the previous formula. You divide by the number of sides. Simple as that. Okay. For these guys, the next part, I believe the drawing a number of sides, you guys can just copy and paste it. Or in your case, you guys can just add on these two columns at the end. So we have these drawings here, and then we're talking about some of each exterior angle. Now, just like before, I told you how the exterior angles is always supplementary, okay? Exterior angle plus the interior angle, they have to give you 180 because that's what it means to be supplementary. I should emphasize the word each. Just one exterior angle, just one interior angle should give you 180. So sum of each exterior angles, well, before that, let's talk about each exterior angles in general. Now before, from the previous slide, we have each interior angle to be 60, 90, 108, and 120 degrees. Now what is the supplementary angle to these guys? That's your first question. Well, each exterior angle here, well, that's going to give me 120, that's going to give me 90, 72, and this would give me 60. Okay, so just like the drawing I gave you before, all of these angles, that's going to be marked in red. Well, that's 120, that's 120, and that's 120. Okay, and if you were to do it this way, that's 90, 90, 90, 90. And so you guys get the idea. The exterior angle is basically the angles that's outside of it. Okay, now I want to find the sum of it. Well, the sum is this exterior angle times how many those are, right? So it's simply whatever this column gave me times n. So times 3, times 4, times 5, and times 6, because those are your number of sides. But notice what happens is that all of these answers that you're going to get is actually there's a pattern to this, because 120 times 3 is 360. 90 times 4 is 360. 72 times 5, yes, you guessed it, it's 360. So 60 times 6 also gives you 360. So what is the pattern here? Sum of all exterior angle, they're all 360 degrees. So that's what this formula, this last part is for. The exterior angles of a polygon always add to give you 360. I don't care if you have n to be 100. Like, imagine a 100-sided length, a 100-sided polygon, but it's not going to matter because it's still going to give you 360 degrees for the sum of exterior angles. Okay, it's just that simple. Now, how do we find each exterior angles? Well, each exterior angles would be 360 divided by n, just like how it was the summation of interior angles divided by n. Okay, so these would be how you would solve it. Let's do some practice questions here. I'm not going to go over all of these. You guys can do this as a classwork on your own and just to get a little bit of a practice. That's not for a grade, but I would like you to practice it on your own. If you want to show that to me on your homework page for your classwork, then that's great. But what I'm really checking is that the file that I've uploaded for you. So please work on that on a separate sheet of paper. The number of sides of a convex polygon is given. Find the sum of the measures of the interior angles of the polygon. So I'm going to be doing the even numbers here, 2 and 4. The number of sides n is 12, number of sides n is 16. Find the sum of the measures of the interior angles of each polygon. Well, that's pretty simple, right? N minus 2 times 180. So 12 minus 2 times 180 gives me 10 times 180, gives me 1800 degrees. Well, that's the sum of the each interior angles. If I were to ask you to find one interior angle, then you would just have to do 1800 divided by 12, which would give me 150 degrees, and so that would be fine. N minus 2 times 180 for this one once again, and so 16 minus 2 times 180, 14 times 180, and I believe if we could just use the calculator for that one, let's see, give me 1 second. So 180 times 14 should give me 2,520 degrees. Again, to find one interior angle, you would take the sum, which was 2,520 degrees, divide by how many number of sides that was, and you will get 157.5 degrees, and that should be it. Okay. The sum of the measures of the interior angles of the convex polygon is given. Find the number of sides. So you're kind of going backwards. Let's say I have 1980 and I have 1800. Set it equal to the formula once again. 180 times n minus 2, 180 times n minus 2. What's my first step? Please divide both sides by 180. Divide both sides by 180 because that's how to get n by itself. We want to isolate the n. We want to peel the onion. Cancel these out. For this one, you get n minus 2 is equal to, I believe it's going to give me 11. And then, so n is going to be 13, because if you add the 2 on both sides like this, these cancels out. 11 plus 2 is 13. This one, n minus 2 is 10, so n is 12. Okay, moving on. The number of sides of a regular polygon is given. Find the measure of each interior angle of each polygon. Well, that's pretty much the same as this one. Take the sum and divide by n, so that's really redundant. Now, last one. Find the exact measure of each exterior angle of the regular polygon. So let me do 17 and 19 again. Talked about heptagon. Ooh, heptagon. I believe that Greek prefix for hepta. Did I make a mistake here? Oh, I see. I'm sorry. So could you guys go back to this one? And it's not septa. I'm sorry. It's hepta. For some reason, I thought it was septa for some reason there. Okay, so septagon means it's 7-sided length right there. So 7-sided length, n is 7. And so each exterior angle. Well, we want to find out one exterior angle then. Summation is always 360. Divide by the number of sides. Well, that's going to give me, let's use the calculator here. 360 divided by 7 gives me 51.42 degrees. Round to the nearest hundredth for me, please, and that should be fine. Last one, 18 gone, because there's really no Greek prefix for like 18. 18 times, well, 8, doesn't matter the number of sides, right? It's 360 divided by 18 always. So 360 divided by 18 gives me exactly 20 degrees. So that should be the answer how to do these questions. Of course, your homework question is going to have something just a little bit differently from this, but it should be very, very similar. Okay, hope this video helped. Please upload it on Google Classroom via picture slash PDF file or scan document or something like JPEG file. Nothing else. If you can't upload it, please send it to my email. And that should be it. Okay, good luck. Have a nice day.